Activity 2. Data-driven decisions. Sometimes a robot needs to change its behavior based on changes in the environment. In order to do this, we need to give our robot data or information from a sensor and then use that data to drive something on the robot. In this case, we're going to change the motor power based on the ultrasonic sensor reading. Open 4H Book 2 Projects and click on the plus sign beside your previous program to add a new program. Double-click on the word Program in the tab. Change the name to Data-Driven Decisions. In the last activity, we used the Action, Flow Control, and Sensor palettes. This time we are also going to add in the Data Operations and Advanced palettes. From the Sensor palette, select the Ultrasonic Sensor block. The infrared sensor looks very similar, so be sure you are grabbing the correct block. Drag the ultrasonic sensor block up and connect it to the start block. This is where our data will come from. Now, grab a Move Steering block from the Action palette and connect it to the sensor block. Change the type to On for seconds and change the type to 1 second. Leave the steering at 0. Now we want to feed the distance from the ultrasonic sensor into the motor power of the Move Steering block. Grab the output wire from the ultrasonic sensor and plug it into the motor power on the Move Steering block. That means that the greater the distance the sensor is reading, the more power the motor will have. It will run for 1 second, but the distance it covers will be different based on the motor power. The program has the basics needed, but let's make it even better. First, let's add a brief wait at the beginning of the program so we have time to start the program and put something in front of the sensor. Then we will want to get some feedback to let us know that the sensor saw the object that we placed. To do this, we'll add in a compare block from the Data Operations palette after the ultrasonic sensor block and a switch block from the Flow Control palette following the compare block. We can grab another output wire from the same place on the ultrasonic sensor block and plug it into the A section of the compare block. In the B section of the compare block, let's put 100. We also want to set this to use the greater than comparison. This will compare the number coming from the sensor with the number 100. If the number from the sensor is greater than 100, it will send out a true signal. If the number is less than 100, it will send out a false signal. But where does that signal go? We need to change our switch block so that it can accept that true or false signal. Change the switch type to logic. A logic switch will watch for a true-false signal and then direct the program to the top section of the switch if it received true or to the bottom section of the switch if it received false. Now, connect up the wire from the output of the compare block into the input of the switch. On the top section of the switch, let's put in a sound to let us know that an object has been detected. From the Action palette, drag up 2 sound blocks. To select your sound, click on the file name box and then select Lego Sound Files, then Information. In this folder, you will find several sound files to pick from. For the first one, let's select Object. For the second sound block, select the detected sound from the same folder. Now, select both sound blocks and copy and paste them and then drag the new blocks into the bottom of the switch. Note, if you have both blocks still selected, you can't change the file name. Be sure you only have the first block selected. Change the first audio block on the top to say No, which can be found under the Communication folder, and the second block to say Object. Finally, let's make it so the program will stop if no object is detected. We can do that by dragging another Stop Program block into the top section. Be sure to connect the Stop Program as shown here to be sure it's linked up properly. Before we save and download our program, let's take a second to review what we did. First, we added a wait block so that the program doesn't start right away. Next, we added the ultrasonic sensor block, which is used to detect objects placed in front of the sensor. After the ultrasonic sensor block, we added a compare block. This block checks to see if there's an object within 100 centimeters of the ultrasonic sensor. If there is an object, it will return a true value. If there isn't, it should return a false value. Following the compare block, we added a switch block, which takes information from the compare block and moves the program forward based on the true or false value from the compare block. If true, the program moves forward via the top path. If false, the program moves forward via the bottom path. In the top path of our project, we added 2 sound blocks which will make the robot say, "Object detected." Following that, we added a move steering block outside of the switch which will make the robot move forward for 1 second. Following this block, there's a stop program block which brings our program to an end. Let's go back to the switch block we added and review the bottom path for when the switch block reads false. Via this path, we added 2 sound blocks to say "No object." And following the sound blocks, we added another stop program block which ends the program. Be sure to save your work. Connect your robot to your computer and download the program. Unplug your robot and run the program. Now, look into your book for some ways to revise this program and then move on to the next section.